Through the medium of science fiction, society constantly imagines what exciting technological marvels might be waiting for us just around the corner. Sometimes these visions of the future arrive almost exactly as imagined. Take, for example, the two-way radio watch from the Dick Tracy comic. This conceived device now exists as a cell phone watch, available from Samsung and Fossil. There are other visions of the future that sound exciting, create a consistent theme across the genre of science fiction as a whole, but have yet to come to fruition. Everyone dreams of the day when we can drive our flying car to work, cutting our travel time in half, while avoiding the gridlock on the streets below. But this, and other imagined technologies, have not panned out for average consumers just yet. Another pervasive example of the unachieved, which has spanned science fiction for the past 30 years, was also featured on Star Trek. Who wouldn't want the endless possibilities of eating whatever worldly cuisine we desire? The unbounded dining prospects created by a food replicator certainly sound much better than the sad reality of a cold sandwich out of a vending machine. But alas, scientific reality is not always quite as flashy and inspired as in the movies. Perhaps it is better to come to terms with the science that is, than to dwell too long on what might be. One area of scientific research that has promised to bring exciting applications to consumers is manufacturing with nanotechnology. After around 20 years of development, nanotechnology-based products are not just coming to market, they might be in your house, pocket, or garage today. Nanotechnology is a branch of science and industry that builds processes and products on a very small scale. High school chemistry has taught us that all physical matter around us is built out of collections of tiny particles called atoms. Nanotechnologies build their individual components at this same size, on the atomic scale. The very small size of the active components used in nanotechnology offer advantages and novel applications for usage. Their small size allows for the components to enter and work in places that would not be accessible for larger components. This can be useful for medical applications like surgery or drugs, where the size of the new devices or substances can work within the smaller spaces inside of living systems. The size scale of nanoproducts has another advantage. Chemical interactions occur at the atomic level, which is exactly where their size is scaled. The size of the particles involved, and the greater surface area created by having vast amounts of tiny particles, create unique properties for these new nanocreations. These unique properties make nanoparticles very useful for lubrication, surface coatings, and filtration applications. Given that manufacturers who currently sell products in the United States are not required to disclose if there are nanomaterials in their products or processing, knowing the exact count of how many products contain them is a challenge. Resources to inform consumers about the presence of nanotechnology in the marketplace are available. One such online resource is called the Project on Emerging Nanotechnologies and is located at the address seen here. This web page offers information about which products contain nanomaterials, current knowledge about these products and their components, as well as the function of the nanomaterials and possible exposure pathways. Their list of products that incorporate nanotechnology currently has 1,854 listings. There are food, cosmetics, sports equipment, electronics, spray lubricants, toys, and clothing within the listings today. Given the range and number of products, including nanotechnology today, odds are good that you or someone else in your household uses some of these types of products. The goal of people running efforts like the Project on Emerging Nanotechnologies are to encourage consumers to become more informed about the possible downsides of these new technologies so they can make informed decisions about their use of such products. This emerging technology has a transparency problem that resources such as this website are looking to shed some light on. Without this transparency and attention front-loaded as the technology arrives, some fear that the safety measures, legislation, and industry practices that may need to be addressed will happen after the fact, when remedies will only balance harms which have already occurred. This is seen as an opportunity to do the right things early instead of having another potential DDT or BPA pulled from the market years down the road. If industry and politicians see intensified interest in the consumer arena for nanotechnology, then it is more likely that they will take the public's attention and concerns into consideration when making decisions or planning regulations. When substances are reduced to a nanoscale size, some of their physical and chemical properties change. This change is part of what helps them accomplish some of their novel effects, which create new uses. Sometimes these changes can create effects that might be problematic for people or the environment if these nanoparticles end up in places where they were not intended to go. Examples of this include accidental inhalation of the particles, accidental ingestion of the particles, and the particles ending up in water supplies. Food production creates an understandable framework which we can use to examine current regulations of food additives, including the use of nanoparticles in food. Under current regulations, nanoparticles are treated as equivalent to larger-sized particles of the same substance. This is handled by a practice known as GRAS, or generally recognized as safe. Because large-sized food particles are used in food and cosmetics without adverse consequences, then nanoparticles of this same compound can be used in the same way. This approach is problematic for an important reason. Nanoparticles can have the possibility of enhanced toxicity or unintended interactions with living tissue at specific nanosizes that do not occur when particles exist at other sizes. For example, titanium dioxide, which is a very popular nanoparticle used in hundreds of the products currently available, has been shown by research to be harmful to human lung cells at a specific particle size. These types of concerns create an imperative to research particles at specific sizes before products using particles of that size are declared safe if they present any realistic exposure threat. Perfect examples of where this would make sense include cosmetics, food products, dry particulate compounds, and aerosol sprays. As a consumer, the first step is to investigate what products are available and to educate your household on the benefits and possible risks of using these products. This information can be gathered from the online clearinghouses about nanotechnology, magazines, or online news sources that feature scientific pieces. Knowledge about nanotechnology products and their current levels of regulation will help consumers decide if the labeling of such products or changes in their regulation are important to them as participants in the political process. Then, armed with this knowledge, consumers will be able to make the purchasing and political decisions that make sense to them based upon informed understanding of the nanotechnology marketplace as a whole.